All right, welcome back. Now we're going to talk about the last little bit of this particular lesson, which is accuracy, precision, and percent error. Accuracy and precision are words that are oftentimes used interchangeably, but they're not exactly the same. So, accuracy is how close your measurements are to an accepted value. So, for example, the height of a basketball rim should be should be 10 feet tall of the rim is 10 feet. Okay. Um, However, if you get one of those adjustable basketball hoops like at the house, you can adjust it anywhere between like 6 feet and like 10 feet. So maybe you might have one that's like adjusted currently to like 9.6 feet. And if you have it at 9.6 feet, that's great, but it's not exact and it's not accurate. So accuracy is when you have a measurement that ends up being exactly what it's supposed to be, or really close to exactly what it's supposed to be. So for example, maybe being 10 foot exactly on your basketball rim, or being really close, like being 9.9 feet, or 10.1 feet. In the case of the lab, if I tell you that I want you to measure out 3.0 grams of a substance and you measure out 3.0 grams, that's really accurate. If you measure out 3.9 grams, that's not nearly as accurate. So here's an old example of using a bullseye and somebody shot some arrows at a target, right? In this bottom corner right here, we are accurate. So we hit the bullseye 4 times, and those arrows are in a tight cluster together. Whereas up here in the upper left-hand corner, we are not accurate because we didn't hit the bullseye once, and they're kind of like spread out and just kind of all over the place. Accuracy is how close you are to getting the correct value when you measure something. Precision, on the other hand, is how consistent your measurements are to one another. Meaning, if we go and we measure the basketball hoop and it's 10 feet, and I measure the basketball hoop and it's 10 feet, and somebody else measures the basketball hoop and it's 10 feet, that's precise because we made the measurement and it was the same measurement over and over and over again. So here in the lower left-hand corner, we have accuracy versus precision. Accuracy, very accurate. All 4 of the arrows made it into the center of the target. Precise, those arrows are grouped really close together, so that makes them really precise. Here we have another example of precise. The arrows are really close together, but they're not accurate because they're not in the center of the target. So if we go back to the example of measuring out a substance, and I say get 3 grams of the substance, and you get 2.9 grams, and your lab partner gets 2.9 grams, and I get 2.9 grams, those are precise because the measurements are really close to one another. They're also sort of accurate because they're really close to the value that you're supposed to get. So that's what accuracy and precision is. Now, percent error is a mathematical equation or formula that allows us to see how accurate we were in the lab. And is it in a way to like use this to use an example here? If I said that the accepted value for a basketball hoop is 10 feet, right? And the experimental value of the basketball hoop was like 9 feet, 9.6 feet, right? If I go and I plug that into my formula here, I can see that I'm going to take the percent error, which would be equal to the value accepted, which in this case would be 10 feet, minus the value experimental, which in this case would be our basketball hoop that's a little short as 9.6 feet, over the accepted value, which would be 10 feet. And then we do the math on that and multiply times 100. But to kind of walk through that point, I'm going to take and do the steps out here. So we have percent error would be equal to, let's see, 10 minus 9.6, I believe is 0.4. So 10 minus 9.6, Yeah, it's 0.4. I knew that. Silly. So it's 0.4 feet over the accepted value, which is 10 feet times 100. And then we're going to divide that out. So 0.4 divided by 10. 0.4 divided by 10 is 0.04. So again, our percent error will equal 0.4. I'm sorry, 0.04 times 100. And so the actual percent error here is 4%. And what I like to tell students when they're recording their percent error is to always like round it to have 2 decimal places, um, just because it makes it a little bit easier. So when we record our percent error, we're going to record our percent error.
High school buses are pulling in 2 minutes.
So we're going to round percents to 2 decimal places. Because it's just easier to do. All right, so that's an example that's not necessarily class-based. So we're going to do another example that's a little bit closer to class-based, going with this one right here. So we have it, a student experimentally determines the mass of the sample to be 9.76 grams and is told that the accepted mass is 9.82 grams. So our value accepted is 9.82 grams. Our value experimental is 9.67 grams. So we're just going to use our formula. So we know that percent error is equal to value accepted minus experimental over value accepted times 100. So when I go and I plug in my values, percent error is equal to 9.82 minus 9.67 over 9.82 grams. Times 100. So I'm going to do a little bit of subtracting here. So I'm going to take 9.82 minus 9.67, and I get 0.15. So we have percent error. I'm just going to continue going along, showing the work, is equal to 0.15 grams over the 9.82 grams, and that's still going to be times 100. So 0.15 divided by 9.82, 0.15 divided by 9.82
Attention student, Angel Fraser, please come to the office.
gives me a percent error of 0.015274949 times 100, and that ends up being 1.5%. So but we're going to round it to 2 decimal places, so it's going to be 1.53% error. Now, the other thing that I want to say about percent error is that the closer to zero you are, the more accurate you were in the lab. So the closer to zero your percent error is, the more accurate your lab is, or lab measurements are. Okay. So that's something important to note, is that we want our percent error to be really small. We don't want it to be big. All right. So that sums up lesson 6, or unit 1, lesson 6. And you'll have some practice with this very shortly. But for now, that's where we're at, and we'll touch base and talk soon if you have any questions.